Alrighty, y'all, Mr. Montana here. So what we're going to be talking about today is lesson 9.0. We're talking about simplifying radicals. So the radical symbol is the square root symbol. That's how we've taught it to you. It is that little house thingy. It's on your calculator. So a lot of this you can do in your calculator, but we need you to understand how to do it by hand, because if questions are asking for something in simplest radical form, unfortunately, that is something that you're going to have to be able to do by hand. All right. So there are some steps right here. We do need to make minor modifications to these steps, y'all. On step 3, go ahead and mark out the word inside and write outside. And then right here on step 4, mark out outside and write inside. All right. That's my bad. We're going a little too quick. My bad. All right. So step 1 says to break down the number until it can't be broken down anymore. In other words, y'all, what you're going to ask yourself is, what two numbers multiply to get this number? Okay. Then you're going to circle the numbers that can't be broken down anymore. Okay. So you want the only factors to be 1 in itself. So for example, if you're talking about 2, the only two numbers I can multiply to get a 2 is 1 and 2. That can't be broken down anymore, so I'd circle above. Okay. Numbers that have a pair are going to go outside of the radical, okay? And then the lonely numbers go inside of the radical. So let's talk about outside versus inside. It's pretty self-explanatory. I'm going to draw a little radical here. This is going to be inside. And this area right here that I'm underlining is going to be outside. All right. Let's go ahead and take a stab at question 1 here. We are given radical 24. So what we're going to do is we're going to start doing a factor tree. So what two numbers can multiply to 24? Well, you can probably think of a few, but let's just go for 2 and 12. All right. Can 2 be broken down anymore? No. So I'm going to circle it. All right. That's an important number. We'll need it later. 12. What two numbers can multiply to 12? Well, you probably thought of 2 times 6. Well, we already said 2's can't be broken down anymore, but 6 can. And then we get 2 times 3. Circle my 2, circle my 3. And then now I need to group things in pairs, all right, if I can. So this first 2, does it have another 2 that it can pair up with? Yeah, this 2 just right next to it. So I'm going to go ahead and highlight those, circle those together. You can do whichever way you think was going to work best for you. So something like that. And so since it's a pair, we look at step 3. It's going to tell me that it goes outside the radical. So I'm going to go ahead and write my radical symbol. Okay, radical symbol. And I'm going to put a 2 out here right now. Okay. And then I keep looking. Next thing I see is another 2. Well, this 2 doesn't have something to pair up with. It has no friends that it can make. So then I leave it, and I look at this 3. Well, the 3 has no friends it can add up with either. So what I do is I put the lonelies inside and multiply them. So my final answer would be 2 radical 6. And that is because 2 times 3 is 6, so the radical 6 just stays inside. All right, moving on to question 2. Let's move this one a little faster, okay? So we are only breaking down the thing inside the radical. So what two numbers multiply to 48? I always pick out a 2 with my even numbers just to keep it as simple as possible. So we get 2 and 24. 2 can't break down, so I'm going to circle it. 2 and 12. Circle my 2. 2 and 6, circle that 2. 2 and 3, circle the 2, circle the 3. All right, now I'm going to do the same thing, find my pairs. Oop. So this first 2, it has a buddy here, okay? Since it has a buddy, it's going to go outside the radical, so I have my first 2. Now, this 2 right here. Oh, it actually has a buddy. So it is also going to be able to go outside the radical. And then this 3 right here. Unfortunately, my 3 doesn't have a buddy, so it is going to go inside the radical. And then if I look at the very beginning of this question, I should see, I've highlighted it in pink, this -2 that's sitting outside the radical. Well, that -2, it still has to be kept into the equation. So all I do is I tack it on up front. So now what I'm going to do is -2 times 2 times 2, and I should end up getting that -2 times 2 times 2 is going to be -8, and then radical 3 stays the same. Question 3. Question 3, we are going to do the same thing. Well, these are pretty big numbers, so I'm going to go 20 and 10. Both of those can break down, so I got to keep going. 2 and 10. Oh, I got my first 2. 2 and 5. And I'm good there. Now I need to look at the right side. Can that 10 break down? Oh, well, yeah, we know. 2 and 5. Okay, so now I got to look for my pairs. Does this 2 here have a pair? Oh, yep, it has a 2 right here. Cool. Solid. I'm going to write it outside of my radical sign. And then now I'm going to ask myself, does this 5 have a pair? Oh, this 5 does have a pair here. Even though it's on a different branch of the factorization tree, it still is able to stay. All right. And then last but not least, I have one more number in a circle, but unfortunately that 2 doesn't have a pair, so it goes in the radical. And then again, I need to look back at the beginning of my equation. Oh, I have a negative. Really, I know that's a -1. So I'm going to multiply everything by a negative on the outside. So 5 times 2 is 10, times -1 is going to make -10, radical 2. All right, moving down over here to question 4. Radical 36. All right, you should already know that the radical of 36 is going to equal 6, but let's see how we actually get there. So what is the radical of 36? Well, 6, or what's this reduction of 6? 36 is 6 times 6, right? All right, well, those break down. 2 times 3, 2 times 3. That's as far as I can take that, right? And so this 2 pairs up with this 2. This 3 is going to pair up with this 3. And so what that tells me is that inside the radical, I'm going to have goose egg, nothing. But outside, I'm going to have a 2 times 3. Well, this cancels, and I'm left with 6. Right? So that is how radical 36 equals 6. All right, when we're dealing with the fraction, it's not any harder. All right, it's saying we're taking the radical of both things. It's taking the radical of 3 and the radical of 9. All right, so when we're doing this, all right, what you need to understand is that this is also the same as if I wrote it like that. Okay, so what 2 numbers multiply to get 23? Well, unfortunately, the only 2 numbers are 1 and 23. So this is actually as far as I can take it. All right. And then what 2 numbers multiply to 9? Well, 3 and 3. And those are going to be as far as I can take it as well. So this 3, does it have a buddy? Yeah. And does this 23 have a buddy? Nope, it doesn't. So what I can do is I can now take this and say, well, inside the radical, that 23 is going to have to stay because it didn't have a buddy. But underneath, the 9 was able to break down, and everything happened to be outside. So there's no radical on the bottom. I will tell you that if you have a radical on the bottom, y'all, you have definitely made a mistake, all right? There should never, ever, ever be a radical on the bottom. All right, now we're going to go here. So, like I said, this is the same as radical 12 over radical 4. So let's see 12. Well, that breaks down to 3 and 4. Then 2 and 2. That 3 stays. The 2's stay. And now I need to look. Well, my 2's have a pair. And so that's going to be 2 radical 3 over. Now let's handle this 4. That's going to break into 2 and 2. Those are going to be its own pair. And so really that just stays on the outside of the radical and nothing inside the radical. Well, guys, this can still simplify more, right? Because this is multiplying here by this radical 3, and this is just dividing the whole thing. So that will cancel out, and I am just simply left with radical 3. All right, head on to the next page. All right, when we are adding and subtracting radicals, all right, adding and subtracting radicals, when we are doing this, it's pretty easy. It's like we're adding and subtracting with x's. So if we were to say 3x plus 3x, you should be able to tell me that that is 6x, right? So in other words, my other radical would be 3 radicals of 5 plus 3 radicals of 5. Well, that's just going to be 6 radicals of 5. Okay? That radical 5 almost acts like your variable. All right? So now we're going to go here. 3 radical of 7 plus 2 radical of 7. Well, that's 5 radical of 7. Here, 10 radical of 3 minus 7 radical of 3. Well, I'm going to subtract the 10 minus 7. So I get 3 radical 3. And now here, I have 3 radical of 12 plus 2 radical of 3. And you should be able to see that that radical 12 and radical 3 are not the same, right? And so what I have to do here is I actually have to see if I can break these down any, okay? So I'm going to take my 12 and see if I can factor it down. Get a 3 and a 4, a 2 and a 2. All right. So really, going to bring that 3 down right here. I have a pair of a 2 and then a radical 3 here because it was by itself. Okay. So I get 6 radical 3 plus 2 radical 3. Oh, look, I now have the same radical. So I'm able to add these. So 6 plus 2 is going to be 8 radical 3. All right. 10. It says, find the exact perimeter of a rectangle that has a base of 4 radical 5 and a height of 5 radical 9. All right. So again, that's going to be one of those where we have to break it down. So I'll go ahead and we'll look at the 4 radical 5 first. Well, guess what? 5 doesn't break down. So this is just simply as far as we can take it. So that's good. But what about 5 radical 9? Well, when we look at 5 radical 9, that 9 can break down into sets of 3. Since it has a pair, I can move it to the outside. So I get 3 times 5 radical 0. That radical 0 is going to go away, and I'm left with 15. All right? And so this side right here is really just 15. So now, if I wanted to find the actual perimeter, I could do 15 plus 15 plus 4 radical 5 plus 4 radical 5. And so I can add these two things, and then I can add those two things separately. So 15 plus 15 is 30. And then 4 radical 5 plus 4 radical 5 is going to be 8 radical 5. And that would be my final answer there. All right. Multiplying radicals. Multiplying radicals, you use the rainbow method, all right? So basically, this is saying I'm going to take the numbers outside and multiply those. And then I'm also going to take the numbers inside and multiply those. All right. I like to call this clam. It looks like a clam to me. So 2 times 5 is 10. Then I draw my radical sign. 3 times 2 is 6. And that's it. So then here, 5 times, oh, your imaginary 1's here, and 2 times 6. So I get 5 radical 12. All right. And then if we look at this 5 radical 12, this could actually technically be reduced down a little bit more. I don't know if we'll necessarily go into depth like this, but just in case we do. So 5 times 2, so that's my pair, radical 3. So really, this could be also 10 radical 3, which is equal to 5 radical 12, all right? And guys, you're going to have a calculator, so really all you'd have to do, type this in your calculator, it'll give you a decimal, and then type your answer choices in and see which one gives you the same thing, okay? All right, here. So now our 1's out front instead. So 1 times 4 is 4. And then 6 times 12 is going to give us 72. And again, that's going to be one of those that can be broken down and simplified more. And when we do, we're going to end up getting 12 times 6, 2 times 3, 2 times 6, 2 times 3. So this 2 and this 3 are ends. This 3 matches with this 3. This 2 matches with this 2. And well, I have my lonesome 2 right here. So it's going to go on the inside. So I get 4 times 2 times 3, radical 2, which is 4 times 3 is 12, times 2 is 24. Radical 2. All right. And that's if it wanted in the absolute most simplistic form. All right. Now it wants us to find the exact length of the hypotenuse, knowing that this is a right triangle, all right? So since it's a right triangle, we can use our Pythagorean theorem, which is c squared equals a squared plus b squared, where that's my x, aka my c, because it's opposite of the 90-degree angle. And then a and b, doesn't matter which one you pick as a, doesn't matter which one you pick as b, all right? And then I just plug in. So I get x squared equals radical 20 squared, and make sure you put it in parentheses here, okay? If you don't, it's really gonna mess you up when you type in the calculator, okay? And so radical 20 squared is actually just gonna be 20, because squaring a square root is the same thing as taking the square root of a square. It's gonna cancel out. So same thing here. So I get x squared equals 20 plus 34, so really x squared, squared, equals 54. And then I'm going to take this radical of 54. So x equals radical 54. And then we have to be able to test, can this factor down? Well, fun fact, it can. And your factors are going to be 6 and 9, to 3 to 2, to 3 to 3. That 3 pairs with that 3, but unfortunately this 3 doesn't have a friend, and this 2 doesn't have, this 2 doesn't have a friend, right? So my people with friends go on the outside, and my people without friends go on the inside. So that was a roundabout way of saying that this side is really 3 radicals of 6. All right, y'all, if y'all have any questions, make sure to ask your math teachers.